students, let's do lines and angles exercise 16B. Exercise 16B is on page number 192. In questions 1 and 2, here we have question 1, we also have question 2. In questions 1 and 2 given below, identify the given pairs of angles. Now can you see, this is one pair, this is another pair. All these are the different pairs of angles given to us. We have to identify that as corresponding angles, interior alternate angles, exterior alternate angles, adjacent angles, vertically opposite angles, or allied angles. Now look at this figure. Here you can see a straight line which has cut two other lines, isn't it? So any straight line which cuts two or more given straight lines is called a transversal. So this straight line is a transversal. So when a transversal cuts two lines, there are 8 angles that are formed. Can you see? 1, 2, 3, 4, 5, 6, 7 and 8. 8 angles are formed and they all have different names. Now we are going to identify these pairs as the names given here, what kind of angles they are. So let's look at the first pair given. We have angle 3 and angle 6. This is angle 3 and this is angle 6. Now these are the angles in red, angle 3 and angle 6. Now what angles are these? Now if you look carefully, they are inside these two lines, isn't it? They're inside it. Like 4 and 5, or 3, 4, 5 and 6 are inside these two lines. That means they are interior angles. And this is on one side, angle 3 and angle 6 is in the alternate side. Okay, so angle 3 is here, angle 6 is on the alternate side. So they are inside, that means interior, and they are on the alternate side. So what are they called? They are called interior alternate angles. So angle 3 and angle 6 are interior alternate angles. Next one, angle 2 and angle 4. So angle 2 is here and angle 4 is here, right next to each other. So you can see angles 2 and 4 clearly now. Now if you can see, they are on this straight line. 2 and 4 are on this straight line, and this is one angle and this is the other angle, and they share the same arm. They share the same vertex, and the other arm is on the opposite sides of the common arm. So such angles 2 and 4 are called adjacent angles. So 2 and 4 are adjacent angles. Let's look at angles 3 and 7. So we have angle 3 here and angle 7 here. What angles are those? So these two angles 3 and 7, as you can see, they are on the same side, isn't it? They both are on the same side, but one is inside this and one is outside. So angles that are on the same side but one in and one out are called corresponding angles. So they are called corresponding angles, angles 3 and 7. Now let's look at angle 2 and angle 7. So angle 2 is here and angle 7 is here. Now angle 2, as you can see, is outside. Angle 7 is also outside. So both are outside. That means they are exterior and they are on the alternate sides. They are not on the same side. They are on the alternate sides. So angle 2 and angle 7 are exterior alternate angles. Then let's look at angle 4 and 6. Angle 4 is here and angle 6 is here. So let's look at angle 4 and angle 6. Now can you see these two angles are inside. They are both inside and they are both on the same side. So they are called co-interior angles. Both are inside. They are called co-interior or allied angles. So co-interior or allied angles. Now let's look at angle 1 and angle 8. Angle 1 is here and angle 8 is here. Let's look at those two angles. So let's look at angle 1 and 8. 1 is here and 8 is here. As you can see, both are outside and they are on the alternate side. So they are exterior alternate angles. Now angle 1 and angle 5. Angle 1 is here, angle 5 is here. So this is angle 1, this is angle 5. As you can see, they are on the same side. But one is outside, one is inside. So such angles are called corresponding angles. Now let's look at angle 1 and angle 4. Angle 1, angle 4, as you can see, they are opposite each other, vertically opposite each other, because these two lines have met at a point. And the angles that are like this are called vertically opposite angles. And now last pair is angle 5 and angle 7. Angle 5 and angle 7. So angle 5 and angle 7, if you look carefully, they are on the same straight line. They have one arm. This is one angle. This is one angle. Now they have one arm that's common to both the angles. They have a common vertex, and the other arm, this arm and this arm, are on the opposite sides of the common arm. Such angles are called adjacent angles. So now we have found and identified the given pairs of angles as all these angles. Let's move on to question 2. Now question 2, here also we've been given pairs of angles, and look at this figure. Now don't get confused when you see the figure. We'll go slowly, we'll take each pair at a time and then find out where they come. So here we have angle 1 and angle 4. Angle 1 and angle 4. Now let's look only at angles 1 and 4. Let's not look at any other angles here. So here if you look at 1 and 4, you can see that two lines, this line and this line, have met at a point. They have intersected at a point. So when two straight lines intersect at a point, the angles that are formed opposite each other are called vertically opposite angles. And as you can see, 1 and 4 are opposite each other. So angles 1 and 4 are called vertically opposite angles. Now let's look only at angles 4 and 7. So angle 4 is here and angle 7 is here. So look at the two angles in red, angle 4 and angle 7. Now consider two straight lines. Which ones? Now this is one straight line, this is the other straight line, and this has been cut by a transversal, this line. So when a transversal cuts two straight lines, this one and this one, 8 angles are formed, isn't it? And that's how we learned the different types of angles. So let's look at the two angles that are mentioned here. Angle 4 and angle 7. Now this is inside. Okay, this is inside. So that means both are inside, interior angles. And they are not on the same side, but they are on the alternate sides. So angle 4 and angle 7 are interior alternate angles. Now let's look at angle 10 and 12. So we have 10 here and we have 12 here. So now look only at angles 10 and 12. Don't look at any other angles. So here, as you can see, two lines have intersected at a point and these two angles are opposite each other. So they are vertically opposite angles. Now the next one is angle 7 and angle 13. 7 is here and 13 is here. So now we are going to consider this line and this line cut by the transversal, which is here. So now look at angle 13 and angle 7. They are on the same side, but one is outside, one is inside. So such angles are called corresponding angles. Next is angle 6 and angle 8. We have angle 6 here and angle 8 here, and two lines have intersected at a point and these two angles are opposite each other. That means these are vertically opposite angles. Now let's look at angle 11 and angle 8. Angle 11 is there and angle 8 is here. So angle 11 and angle 8 are both inside. As you can see, they are both inside this and they are called co-interior angles or allied angles. So let's write that. Co-interior angles because they are inside and on the same side. Now look at angle 12 and 9. They are outside and on the same side. So they will be co-exterior angles. They'll be exterior allied angles. Whereas these two are inside. Now the next one is angle 7 and angle 9. So these are those two angles, angle 7 and angle 9. And as you can see, two lines have intersected at a point and these two angles are on the opposite sides of that intersecting point. So these are called vertically opposite angles. Next we have angle 4 and angle 5. Where is it? Angle 4 and angle 5. So we have those two angles here, angle 4 and angle 5, and they are on the same straight line. They have a common arm and they have a common vertex. So these are adjacent angles. Angle 4 and 5 are adjacent angles. So we have angle 4 here and angle 6 here. As you can see, they are inside and they are on the same side. So they are co-interior angles. Co-interior angles. Angle 6 is here, angle 7 is here. If you look carefully, they are on the same straight line with a common arm and a common vertex. So they are adjacent angles. Let's look at angle 2 and 13. Angle 2 is here, angle 13 is here. So they are both inside and they're on the same side. So they are co-interior angles. So now we have identified the different pairs of angles. Question 3. In the adjoining figures, okay, so this is the first one, there are more figures. The arrows indicate parallel lines. So can you see these arrowheads? That means these two lines are parallel lines. State which angles are equal and give reasons. Okay, so when a transversal cuts two parallel lines, 8 angles are formed and there are certain properties of those angles. So we need to say here which angles are equal. So let's start with angle A. Angle A is equal to which other angle? If you look carefully, angle A is equal to angle B because they are on the same side. One is inside, one is outside. They are corresponding angles, and when a transversal cuts two parallel lines, corresponding angles are equal. Okay, so angle A is equal to angle B. Let's write that. Angle A is equal to angle B as they are corresponding angles. Now, this happens only when the transversal cuts two parallel lines. Now look at angle B. Look at angle B and angle C. You know that they are vertically opposite angles. Now when a transversal cuts two parallel lines, vertically opposite angles are equal. That means angle B will be equal to angle C, whatever the measurement is. So let's write that. Angle B is equal to angle C as they are vertically opposite angles. Now let's look at angle A and angle C. Angle A and angle C are interior alternate angles, isn't it? Now, when a transversal cuts two parallel lines, interior alternate angles will also be equal. So, if angle A is 50 degrees, angle C will also be 50 degrees. So, angle A is equal to angle C as their interior alternate angles. Okay, so we'll write that down. Now, look at angle D. Angle D is not equal to any other angle. Angle D and angle A are adjacent angles, but they are not equal. Angle D and angle C are co-interior angles, but they are not adjacent. They are not equal. Okay, so these are the angles that are equal. So angle A is equal to angle B and B is equal to C. So we can write it this way. Angle A is equal to angle B is equal to angle C. So these are the angles that are equal and we have given reasons. Let's look at the second. Question 2. Let's look at this figure. Here you can see two parallel lines here. Here also two parallel lines and they are cutting each other. That means they form the transversal. That means certain angles will be equal to each other. So let's begin with angle X. Now look at angle X and Y. Can you see X and Y are vertically opposite each other? So vertically opposite angles are equal because we're talking about parallel lines. Okay, so X is equal to Y as their vertically opposite angles. Now let's take Y. If you take Y and L, can you see that they are interior alternate angles? Interior alternate angles are equal because these are parallel lines. So let's write that Y is equal to L as their interior alternate angles. Now let's look at L and N. They are vertically opposite each other. So because these are parallel lines, vertically opposite angles will be equal. So L is equal to N as they are vertically opposite angles. Now let's take N and any other angle that is equal. Let's see what N is equal to. N is not equal to M. Okay, because they are adjacent angles. N is not equal to K because they are also adjacent angles. They are next to each other. They will not be equal, but together they will add up to 180. They are not equal. Now let's take N and R. Now N and R are corresponding angles and corresponding angles are equal. So N is equal to R as they are corresponding angles. So can you see this connection? X is equal to Y. y is equal to L is equal to N, and N is equal to R. So we can write it this way. X is equal to Y equals L equals N equals R. They're all equal to each other. So whatever the measurement of X is, suppose X is 50, Y, L, N and R will also be 50 degrees. Now let's go on to the next part. That is, we have included all angles except K. We didn't talk about K, we didn't talk about M, we didn't talk about Q. Let's see if they are equal to anything here. Now, if you look carefully, K and M, can you see that? K and M are vertically opposite each other, and vertically opposite angles are equal because of the parallel line. So let's write that M is equal to K as they are vertically opposite angles. Now let's look at K. Is K equal to anything else here? K is not equal to Y. K is not equal to N. K is not equal to L. Okay. So now K and Q will be equal. K is equal to Q because they are corresponding angles, or M is equal to Q because both are outside and they are alternate. So they are exterior alternate angles. So we can write one of those. So K is equal to Q. Can you see? K is equal to Q because they are corresponding angles. So what do we understand from this? M is equal to K and K is equal to Q. So we can write it as M is equal to K equals Q. So these are the angles that are equal to each other. Question 4. In the given figure, find the measure of the unknown angles. So here, as you can see, only 110 has been given. All the others are unknown. That is A, B, C, D, E, F and G are unknown. We have to find the measure of all these angles, and we only have one angle given to us. So let's begin by looking at angle A and this angle that is given to us. So first we need to understand that we have two parallel lines cut by a transversal. So the properties of those angles you should know. Now what kind of angles are angle A and 110? Angle A and 110 are corresponding angles because they are on the same side. One is outside and one is inside. They are corresponding angles. And what do we know about parallel lines? Corresponding angles are equal. That means angle A is equal to 110 degrees. So we've got the first angle measurement. Angle A is equal to 110 degrees because they are corresponding angles. Now let's go to angle B. Now angle A and angle B are on the same straight line. That means they are adjacent angles or they are a linear pair of angles. And what do we know about linear pair? That angles on a straight line will add up to 180 degrees. And we already know that angle A is 110 degrees, isn't it? We just found out it's here. Angle A is 110. So we know that angle A is 110. That means to find B, we have to say 180 minus A, or 180 minus 110. So let's write that. B will be 180 degrees minus A because they are a linear pair of angles. So let's do that subtraction. 180 degrees minus 110 degrees, which is 70 degrees. 180 minus 110 is 70 degrees. So now we know that B is 70 degrees. Now together, can you see 110 and 70? They will add up to 180 degrees. Now let's look at angle C. If you look at angle C and angle B, they are vertically opposite angles. And what do we know about vertically opposite angles? Vertically opposite angles are equal. Now you can take it this way, or you can also say angle C and angle A are a linear pair because they're on this line, and you can subtract this from 180, you will get angle C. But this is the easier one. Angle C and angle B are vertically opposite angles, and vertically opposite angles are equal. So angle C is equal to angle B. They are vertically opposite angles. So what is the value of C? B is 70 degrees. That means angle C is also 70 degrees. So now we have found angle A is 110, angle B is 70 degrees, angle C is 70 degrees. Now let's go to angle D. Now it's easy to find angle D because we know B, we know C, we know A. So we can use any one of these angles to find angle D. But the easiest will be angle A because they are vertically opposite and vertically opposite angles are equal. So angle D is equal to angle A because they are vertically opposite angles. And how much is angle A? 110. That means D will also be 110. So we have found the value of angle D. Angle D is 110. So we have found these four angles. Now let's go to angle E. Now again, there are different ways of finding angle E because we have many values. I can say angle E and angle D are co-interior angles. So together they will add up to 180. Or I can say E and 110 are a linear pair. Together they must add up to 180. Or I can say angle C and angle E. C and E are interior alternate angles which are equal. Or E and B are equal because they are corresponding angles. You can use any one of these ways to find angle E. So here we are saying angle E is equal to angle C. As you can see, because they are interior alternate angles, they are inside and they are alternate. So we have found angle C, angle E. Angle E is equal to angle C. And what is the value of C? C is 70. That means E is also 70 degrees. So we have found angle E to be 70 degrees. Now let's move on to angle F. Now angle F also there are different ways of finding. Angle F and angle E are a linear pair of angles. Together they must add up to 180. Or I can say angle F and angle D are equal because they are corresponding angles. Or I can say angle F and 110 are equal because they are vertically opposite angles. I can also say angle F and angle A are equal because they are exterior alternate angles. I can use any one of these properties. So angle F is equal to 110 vertically opposite angles. Can you see this? They are vertically opposite angles and vertically opposite angles are equal. So this is 110, F will also be 110. So we got A is 110, B is 70, C is 70, D is 110, E is 70, F is 110. Now we have to find angle G. Now what are the different ways of finding angle G? I can say angle G and 110 are linear pair of angles. So together they will add up to 110. They will add up to 180. 110 plus another angle will add up to 180. Here also I can say that they are a linear pair and they will add up to 180. I can say G and E are vertically opposite angles, that they are equal. So there are different ways of doing it, of finding the value of G now that we have so many angles. So let's write G is equal to E in this case, because they are vertically opposite angles. So E is 70 degrees. That means G will also be 70 degrees. So have we got everything now? Now let's write 70 here. Let's check everything. We have A, B, then we have C, D, E, F and G. Okay, so we have all the angles. Let's write it down clearly. So here let's write A is equal to 110 degrees. B, we just found out here, B is equal to 70 degrees. C, let's see how much C is. C is equal to 70 degrees. D, D is equal to 110 degrees. Angle E, E is equal to 70 degrees. F is equal to 110 degrees. And G is equal to 70 degrees. So now we have found all these angles. We will stop with this for now, children. In our next video, we will continue with the remaining questions. Thank you, children.